Bonjour, my name is Ali. I work at Google, where I lead the AI cybersecurity research effort for Google and DeepMind. This video is a pre-recording of the talk I'm about to give at RSA 2024 on how large language models are currently reshaping the cybersecurity landscape. Before we get started, if you would like to have the slides, which are presented in this video, you can find them at the URL you see on the screen, or you can find them in the description of the video. With that out of the way, let's get started. So there is a lot of hype around how AI is currently revolutionizing the world, and this is partially due to the emergence of chatbots or LLM, large language model, which are able to process very complex multimodal requests, which include image, text, video, or code, and able to answer questions in natural languages. The ability to talk to the model in plain English, plain French, or whichever language you speak, make it very accessible and far more easy to use than previous generation. And combine that with those incredible capability, have sparked a vast amount of innovation. During this talk, I'm going to call those models large model because those are models which have billions of parameters. The initial versions which were released were text only and known as LLM, large language model. But since then, we have models which are able to use image, text, video, and so forth. So the more apt definition would be a large language model, a large model, sorry. The problem with that, of course, is, as you can see, is everyone is used to use the term LLM. So if I mess up, apologies, but please consider all of them as those multimodal billion parameters model, which are extremely powerful. And so, as I mentioned, the reason why those models are so powerful is they have the ability to not only understand very, very complex queries which are made in human languages, they are also able to generate a wide range of content from text, image, and code. So essentially, you can ask the model to perform quite a bit of a large set of actions, from summarizing a document to help you writing code, to even transcribe something into a markdown table you can put online, or even help you writing a website. And those incredibly large capability is what revolutionizing the world. Google obviously have its own version of that, which is Gemini, and Gemini is able to today to generate for you code, help you reason, help you generate images, and so forth. And all those large language models have been trickling down to various applications, whether they are on science, industry, for chatbot, for support, or even finance. But the question we have today is, how come those models are changing security? And the thesis I have is that AI is disrupting cybersecurity balances by doing two things. So the first thing is it is lowering the bar for attacker by making it easier to conduct attack, while at the same time, it is drastically scaling defender capability by inserting itself into most or many of the workflow we have to protect our infrastructure. And of course, there is a lot of skepticism around AI being a revolution, given the fact that there was already two false starts in the last 3 decades on AI. AI has been touted as the next big thing already 2 times, and we had 2 AI winters, so why not a third one? Well, I think this time it's a little bit different, and so what I propose today is give you a tour of how AI is concretely reshaping cybersecurity capability today from an offensive and a defensive perspective, so you can make up your mind and start to see where it is actually making progress in practice today. I propose we start with discussing how AI is currently reshaping offensive capability. In that realm, a while back, I think in 2002, there was this viral photo of the Pope in a very fashionable garment, which is from a popular brand. And people got very, very excited about it, and there was a lot of discussion on whether it's true or fake, and people started to play detective and quickly realized that, well, the glasses are probably not correct, the cross is a little bit blurry, and of course the hand is clearly not human. And of course people concluded correctly that this image of the Pope, as cool as it may appear to be, is actually a fake. Fast forward, here is an image a few years after, And we can see that the quality of the image is quite better. And for example, the glasses are quite spot on. We don't see the hand, but current model do hand pretty well. So the last remaining bits is maybe the cross is not perfectly attached, but it becomes harder and harder to distinguish what we would call deepfake. And of course, that gave rise, as security professional, as concerned about the weaponization of such capability. And lo and behold, in 2022, there was this deepfake of Zelensky trying to say that Ukraine is going to surrender. Of course, it's a fake. I did plan at RSA to ask the audience which one is a real one, which one is a fake one. For you viewer online, the one on the left is a fake one. It's a little bit blurrier, but you would imagine that on a social network feed, it's not that easy to capture. So very well done deepfake, which was done by nation state, or at least allegedly done by nation state. Fast forward to 2024, 2 years after, the number one concern we have now with weaponization of AI is that those capabilities have been commodized, and the generation of image, audio, or even video is now quite reachable for many, many attackers. And so we are seeing more and more multimodal phishing and scam attacks. And those attacks are going to be more and more prevalent. And this is really one of the key ways generative AI is changing the world. There is also a thriving black market behind those, even for large language model. This is a paper who actually did survey all the black market LLM available, I believe, at the end of 2023 or early 2024. As you can see, there's quite a bit of those. And those LLM do offer a wide range of capabilities. The three main ones advertised be malware, phishing email, and scam website. Those capabilities, according to the paper and testing a bunch of models, seems to be somewhat pretty good on the phishing email side. The malware is probably refining scripts, and the scam side are somewhat okay. And they also looked at the ability of those models to exploit vulnerabilities. And however, when you look at the paper and you look at other papers in the same vein of AI being able to perform exploitation, we can see that this is clearly not working. It's a form of shellcode, but the shellcode of multiple A's is not going to do anything, and the interaction with the system is actually say you have to write it yourself. So the exploitation capability are not there yet. There was other papers I mentioned who did try to do the same thing, and looking carefully at the output, it seems that the model are able to look up online some CVE and so forth, but are not able yet to exploit any kind of software by themselves. On the flip side, we also observe that nation states have started to try to abuse GenAI services. And what it seems to indicate so far is they are trying to use it for translation capabilities, technological research, for example, satellite technology, try to refine some attack script, and disinformation and reconnaissance. And so everyone on the offensive side is finding some use of the model, mostly so far on the content creation side. So if we want to be very concrete today, where does that leave us? Well, for phishing, I think the risk is pretty high, and we're going to see more and more phishing personalized using OSINT or knowledge that the attacker has about an enterprise. The malware risk is somewhat in its infancy. It's not that models are not going to get better at it. It's most likely that as models become better at writing code, they will become better at writing malware to a certain extent. So malware is probably like a low risk at the moment. Misinformation is the highest risk, as I mentioned. There are actually a lot of deepfake services which have been emerging, and we expect to see a lot of AI-driven disinformation moving forward, both for political gain, but also financial gain and scam and phishing, whether it's going to be email, but also video call, fake ID, and so forth. And then the risk of proliferation, which is the one which is where the AI is able to assist people in the way of creating nuclear, bioweapon, or chemical weapon. This risk is actually probably extremely low at the moment. Every assessment done by every large company tend to indicate that it is very, very low, and everyone do alignment to prevent any further proliferations risk. So this one I would rate at the lowest at the moment. Most exciting part for me is how actually AI cybersecurity, AI going to help us as defender regain the upper hand, and how we can really leverage those capabilities to help us succeed. So I think we are still in the infancy of how this technology is going to be deployed. So it seems important to focus, I think, more on the what is the model can do and illustrate it through a concrete example rather than focusing on the exact example. So I'm going to give you 4 concrete examples, but what I would hope you get out of those examples is not necessarily where we are today, but try to imagine where we'll be 2 years from now, because those capabilities are going to get better. So the first one we're going to talk about is how we can leverage the LM reasoning capability through the eyes of scaling content reviews. Then we're going to talk about the ability from the model to understand multimodal content, which is image, text, and so forth, to analyze malicious document and provide meaningful explanation. Then we're going to talk about how code understanding can hopefully help us secure our code base. And last but not least, we're going to talk about generative capability in the context of speeding up incident response. The solutions which are discussed in this talk, of course, are completely model agnostic. You are welcome to use any large language model you like. They should all work equally well as long as they are capable. So, reasoning capability. We want to talk about that in the context of fraud and abuse, where the need to manually review a lot of content have to scale and to an ever-increasing amount of content which is generated, and with, of course, with generative AI, which is able to generate images at in an insane pace, or soon video or audio, the burden on manual reviewer to assess the quality of content and moderate content has become almost unsustainable. So those reviews are very important for quite a few things. Phishing and scam, when the machine learning is unable to detect something or have some sort of boundary decision, you need manual review to help you decide if it was a false positive or not. Misinformation, is it true or false information? Hate and violence and toxicity, of course. And even user report of a product not working or something not being flagged and so forth. So here the opportunity is we can use off-the-shelf large model reasoning capability to perform training-less content classification, which means we can use a model to try to decide what to do without teaching it on the specific use case and benefiting from the generalization capability. So the way it works in practice for zero shot, meaning no information, will be you take user-generated content, you pass it to a large model, which is going to act as a rater, and then you're going to give the model a policy, which is what the model should assess. How is it actually should look at the content and decide whether or not it's violative or not. Then if the model says that's fine, then the content is fine. If the content is potentially problematic, then it is escalated to a human reviewer, which will decide whether or not which it is really a false positive and send it back to it's okay, or agree with the large language model and decide it's an escalation and it's either blocked or escalated or moderated. So that's the basic idea of using the large model as a front end to take on some of the burden from the human writer to focus on the difficult case. And the way you do this is essentially by creating a prompt, which is the instruction you give to the model. And so you pass your policy, as we discussed. Then you ask a question to the model where you say, hey, does the following content violate this policy? And then, of course, you pass what you want to moderate. A few tips for you. The first thing, it is actually pretty useful in our experience to add tags around your policy or around some formally defined part of the prompt, make it easier for the model to understand it, and then it increases accuracy. Second, we found it quite useful to tell the model which actor it is impersonating or replacing, or however you would like to call it. So here, for example, we say, well, you are a content moderator. And then last tip, which is quite useful, is you should start the prompt of the answer by just adding the beginning of the answer yourself. And that will give you a far better performances than just making unstructured data. So what is it good for? Well, the first thing you can use it for is for pre-filtering, meaning, as we saw, the model is looking at a bunch of the content, and then when there is a potential violation, it does escalate it to the human who makes the final determination. The other way to do it is to use the LM as a rater to do rapid escalation. In that case, when the LM doesn't know, it passes it to the human, but if it thinks there is a violation, then it will actually immediately escalate. That might be helpful when you are tolerating a little bit of a higher false positive rate, but you want to react much, much, much faster. The last one is you can use the LM as a secondary reviewer to improve error detection. So the human are still reviewing everything, and then the LM is used as a secondary reviewer who will actually look and see whether or not it agrees with the human. And if there's a disagreement between the human and the large language model, then it is escalated to another human writer, so we have another view of it to decide whether or not there is a violation. And that helps you to further increase the accuracy of your manual review queues in case you need extremely high accuracy. It completely depends on the use case you are considering. Another way, which is very common in the current setups that is worth mentioning here, is to improve accuracy by adding a few shots, which means a few examples that might be helping to support the policy. So what you do is, instead of just passing the policy, you also add a few examples. The way you do this is essentially by adding to your prompt an additional piece of places, which is example, and those are either static submitted, if you basically do prompt engineering and you put canonical example or if you want to do one of the techniques which is the most popular at the moment, which is RAG, which stands for Retrieval Augmented Generation. So basically adding retrieval data, you could probably query the base of known example you have and then find the most likely one and then add them back to the prompt to improve accuracy. We run a few experiments on how good those LLM as a rater without training can perform on a various set of representative use cases we had to test. And we found out that, as you can see, it is fairly accurate. For something is extremely accurate, like election misinformation. And for something which are more complicated, such as harassment or violent extremism, we can see that the performance is pretty good. When you add RAG, which is this augmented example, we can see that in most of the case, it actually did improve quite a bit the accuracy, in particular for the difficult cases. However, you can also see that for the one where we had extremely high accuracy, adding the most relevant example is actually a little bit detrimental. So you will have to figure out for yourself what it works. And so if we look back at the third idea we had, which is can we use LLM to help manual rater, we also found out that asking the large model to flag key sentences inside a piece of text which is potentially problematic actually do help a lot humans, because the human knows where to look. And there's a lot of fatigue in human reviews to decide which part of the text to look for. And so that was very helpful to have the model say, you should look at this and this. This is probably where it's problematic. And that helps accuracy by 9 to 11%. So yet another way where the reasoning capability of the model are quite useful to assist humans into understanding content. So to recap, I think one of the places where large models are going to really help us as Defender is by providing reasoning capabilities that we can really use for training less content. So there is quite a bit of challenges when we try to do those use cases. The first one is the current policy are sometimes ill-defined or not necessarily as defined in a way which is easier for AI to understand. So you'll have to refine your policy and kind of find a way to decompose it into smaller atoms that helps the model make a better decision. There's also quite a bit of tooling involved into bringing those LM into manual review queue, and there's a lot of integration, but then you can get this no-code integration where people are able to interact with the model or draft their own policy and deploy them and test them. It does require to change a lot of workflow, but so far this is one of those use cases where it seems that we are very, very close to be able to leverage them at scale. The upside of that approach, of course, is you get faster response to emerging threat because you don't need to train a classifier. The model can just work from the get-go. And as you supply a few examples, it can improve accuracy. So you have a very, very fast path to do content moderation with them. It does help reduce manual tool, which is very, very important because it reduces the burden put on human by assisting them and helping them do better decision. And that's my third point as well, which is that because you can use them as guardrail, it can act as a second reviewer or help highlight what the manual reviewer should look at, saving time and making it an easier experience for the people who are in charge of reviewing content. Our second use case, multimodal capability, is about how we can analyze malicious documents with a model. So in the last few years, malicious PDF have been on the rise. They've been quite feature heavily in the press. And today, looking at Gmail telemetry, or at least at the time of the recording, early 2024, one of the key challenges is most of the malicious documents which we block on the Gmail side are multimodal. We estimate that about 70% are image plus text or image only, and that text only, which used to be the bulk a long time ago, is now completely superseded by those multimodal malicious documents which are harder to process by traditional antiviruses. And here are a few examples of images which are pretending to be in those documents. And those are full images. They are not like text plus images. They are literally like an image that are put into the document, just to show you what those images might look like. And what you can do, of course, you could have an opportunity to say, like, well, how about we use the same thing as we did in the first use case, which is using a large model to understand that. And it is totally doable. We did the experiment of using Gemini Pro to classify a bunch of samples from various totals, and we have about 91% accuracy. So the problem is that is probably not the best use of LLM, because we have also specialized models which are way, way, way smaller and achieve a higher accuracy. So reviewing content at that scale, because you were talking millions and millions and millions of documents, is very, very expensive if you use a large model, because those are billions of parameters. Whereas if you have that volume, it's probably better to leave it to specialized AI. That is where a specialized model actually shine a lot. So that's probably not, I think, the best opportunity when it comes down to use large language model for malicious content. Instead, we're seeing that the best opportunity is probably around the ability to use large model to analyze multimodal content to provide some sort of understanding of what is happening or what is the type of attack you face. Here's a concrete example. So here's a PayPal order that has been received. It's a fake PDF. Of course, it's a scam, and it asks you to pay $2.99 for Bitcoin. And so when you pass that to a model and you combine it with RAG, then the model is perfectly able to understand that this is a attempt impersonating PayPal, and it should not be trusted. And it gives you quite a set of meaningful reason of why this is a phishing thing. So first one, it tells you, well, the phone number do not match a PayPal support phone number. So that requires you, of course, to know the real number and pass the real number to the model with a multi-turn system. But essentially, the model is able to compare things and able to make a determination based on that, which is quite helpful when trying to determine if a document is malicious or not, and quite akin to what a analyst would do. And then it will also know that the risk is about what is happening, which is they are trying to steal your personal information because they ask you to call a specific phone number. So it's probably like a callback scam. So that gives you an example of where I think the model will shine a lot, which is providing almost analyst level capability with the right information in the right context, and really helping making sense of what is the attack we are facing, and help to with either telemetry understanding or helping pre-process attack. So the opportunity is to have this amazing capability of combining text, image, video, and audio, and throw everything at the model and ask it to perform a complex reasoning. They might be need to fine-tune the model to get the best performance rather than prompt engineering, because some of those use cases are quite complex. And if we talk about even more complex attack, it's probably not in the general training data set. And you can't really scale it to a very, very large volume. So it's going to be for very, very specific type of attacks or for reasoning only. For very large scale, as I said, I think a specialized model will actually trump that quite easily due to performance accuracy ratio. On the other hand, those models are able today to help deal with multimodal attacks. And that's a unique capability to those models or specialized models you have to do, which are also based on the same type of architecture, which is transformers. And then it generalizes across format because it understands the content itself and really can act as an analyst, which helps Defender goes beyond it's good or bad, but also able to understand what was the impersonation, who is targeted, why is it not legitimate, and so forth. So bringing quite a bit of threat intelligence, quite a bit of understanding that we didn't have before. Moving on to code capability, I think that's the big one, that the one everyone is very excited about, is how we can use those to secure our code base. And code base vulnerability is not getting any better. There's a lot of zero-day in the wild. We all want to find bugs faster and fix them. So we had early success of using large language model to help with fuzzing, where basically when the fuzzer is stuck and it cannot get additional coverage, you can use a large language model to look at the fuzzing harness and help enhance fuzzer. So that's one way where there is a lot of promises of combining large model with fuzzing to improve bug finding, and that's one of the places which is very exciting. There are plenty of approaches to do this to secure the code base. GitHub is actively developing an assistant to help detect and fix vulnerability, which is somewhat of a holy grail where you would like to submit a pull request and then immediately an AI can figure out if there is a vulnerability, essentially reducing the windows of vulnerability to 0 because you're able to catch a bug before it even hits the production. And that opportunity has been discussed quite a bit. This is, for example, Jason, which worked at Anthropic, who was very excited when Claude was launched that it was able to understand some of the vulnerability. And the DARPA, which we are collaborating with, and Anthropic as well as OpenAI and so forth, have a competition in the next 2 years around the ability to find and patch vulnerability in an autonomous manner. So really, that is the opportunities that if as a community we're able to achieve, we will really make a massive dent and greatly improve the security of the world. So it's really, really exciting. However, when you look past initial experiment, you realize that actually the models so far do not generalize that well when it comes to vulnerability detection. It seems that it is extremely difficult to do it. There are a few things which seems to be some of the reason behind those difficulty, which might be first that the data set are very noisy. B, we don't have very, very large data set because there is only so many vulnerabilities we know of. And even when we know them, it's very, very hard to really clearly identify which part of the code was vulnerable in the patch. So that makes it quite a bit difficult even for vulnerability detection to be able to train model at the scale we need, or at least fine-tune them at the scale we need. When it comes to patching, we did an internal experiment a few months back. I believe it was in 2023, where we actually took, I believe, 1,000 bugs from Google internal code base, very simple bugs, C++ bugs, buffer overflow mostly. And we had the machine learning model to patch them with the best machine learning model we had at the time. And our success rate, which is measured by how many of those patches were accepted by software engineers, was around 15%. And so that is quite a bit lower than people would expect. But in practice, this is where we are on a code base which haven't been seen during training by the models. And so this experiment was quite interesting because we learned quite a few interesting behavior. The first one is we did see the large model being able to patch. So this is technically somewhat doable. It seems that some bugs, usually the simplest one, are easier than others. And some of the behavior are actually non-trivial and quite impressive. So for example, we had one case where the model was able to add a mutex to fix a race condition, which is not very hard to do, but somewhat a complex idea. So that was very, very interesting. And we also saw the model being able to fix a data leak by removing some pointers. However, we also saw bad behavior. I said 15% is a long way to go. And some of those mistakes were quite difficult to fix. For example, in some cases, the model said that, well, the code is problematic, so let's just comment it out. That leads us to one of the difficult points of making progress in that field, which is you not only need to have a patch which fixes the vulnerability, so you have to be able to test that when you evaluate those type of model, you also need to be able to make sure that the model do not break the code, because obviously otherwise you just comment out everything and it breaks. More subtle and difficult thing to even catch is that for some bugs, the model decided that, well, can't fix the race condition, so I'm going to write the code sequentially and forget about concurrency. So technically correct, however, not what you want, because then the performance degradation is insane. And the last one, which was probably the funniest one, is that the model couldn't fix the bug, so it decided to remove the unit test. And yes, there is no bug anymore, at least reported, but that's not what you wanted. So quite a long way to go, but also highlight that whatever effort we want to do for evaluating and training a model to do patching, we'll have to do a very, very complex data set, which allows us to assess all those dimensions of is the code is correctly patched, is the vulnerability removed, is the functionality all there, and so forth. So that makes this type of research probably one of the hardest to carry out and very, very manually intensive. The last thing I would like to point out is while there is a lot of enthusiasm today for code patching, which I actually do share, this is not a new idea. There was a few years ago some university who did try to submit patches to the Linux Foundation based on AI report, and they ended up being banned because those patches were meaningless. So what I would caution for people interested in doing this type of research is be careful that we need a very, very high success rate before we can actually use it in production, because otherwise it's going to be very, very costly and very tiring for people. So the accuracy needed for those patches is going to be quite a long haul to get there. So this capability, I don't foresee it being online, or at least only in a limited capacity soon, and it's going to be probably more like a midterm capacity if I had to make a prediction. Of course, maybe tomorrow someone come up with an incredibly better large model and then I'm wrong, which is totally possible as well. But as of today, which is early 2024, it seems that we still have a long way to go before we can get to the point where we can submit patches to code bases using a large model. That said, very, very positive on the idea and very excited to see how, as a community, we'll be able to use coding capability to find and patch vulnerability in the upcoming years. To recap, the validation of those bugs is quite complex. We have to create data sets, which is very, very difficult. We have to have a lot of experts collaborating to create data sets which are meaningful and help us to really evaluate and pinpoint how the model will do. And for training, it's going to be even more complicated because there is not a whole lot of vulnerability in the world that you can use. So you'll have to get creative on training data set and how to do it. On the flip side, I think the upside is absolutely massive and will really, really tip the scale in the favor of the defender by essentially eliminating the windows of vulnerability, because if we had an accurate model, the bug will cease to exist, or the vast majority of bug will cease to exist by simply having a checker which will at commit time verify and say, nope, can't have this code because it contains vulnerability, let's instead use that code which have a patch. And I think that is probably one of the biggest upside. So really, really exciting, just not there yet. Last but not least, we can look at generative capability, which is the bread and butter of large model, and how that helps speed up incident response. So during incident response, time is of the essence, and the faster we respond to incident, the better we are, and the better we can mitigate the attacks. And here's the ability of the model to generate a report or to generate information is what's going to help us to speed up incident response drastically, and hopefully by having incident response analysts assisted by AI will be so much faster and would make the life of attackers so much more difficult. So the first experiment we had for that was we ran an experiment with the incident response team at Google. And what was the experiment was write an incident summary and start from scratch versus start from an LLM draft. And what we did measure is how long it takes to write this summary. And this is a chart you see. You see for the same incident, we got the help of our incident response team and they gracefully did it twice. And so if you have the exact amount of time, then there is no time save. However, as you can see, in that experiment, we found that about 51% of time was saved if you start from an LLM draft, meaning that the LLM do the heavy lifting of taking the incident response work log and come up with a summary. And quantitatively, we see that the generated summary by large model are actually quite comparable to the one from humans, whether it is about following the writing guideline or whether they are following the key point. If you're interested into learning more about this experiment, we have a link at the bottom on the experiment. It's in the blog of Google Security blog. And so behind the scene, the trick to get a lot of performances is very similar to our first use case, which is make sure to be very, very principled around what type of information you want and structuring very, very carefully each of the fields using tags that you can see. And so the structured prompt actually works pretty well for incident response. And we expect to have large model helping incident response to be quite the norm in the next few years. And so this capability of having large model being able to generate content to help incident response, of course, does not apply only onto summary. That was just an initial idea. There are plenty of places where they have their place, and we will have to carefully make sure they are helpful and they are actually on par to what a human can do and can help speed up the workflow. But there is quite a few workflow which I think that's going to really help us as Defender regain the upper hand. The difficulty here is, of course, the data input is quite complex and you have to be very well structured. So you need to have a very mature incident response system and practices to be able to get those summary to be just right. So far, we only have been able to speed up summarization. There might be other areas such as root cause analysis, which are also very important, but need to require a little bit more work because they have to understand, as a model, have to understand the file format and the logs and whatever data you have. So there is quite a bit of additional training maybe required for that. And of course, it does require still to have the human in the loop, and we are not to the place where, or at least Google is not into a place where we are confident that you can just use them without human supervision. And I don't think that's a good idea so far due to potential hallucination, incomplete information, or maybe errors. 51% means we're cutting in half the time spent, which is already quite a massive win. And the other benefit besides this 51% summarization speed up is that we get more consistent summary, because then the draft created by the large model follow quite well the guideline, and so the analyst, when it reviews the summary and help enhance it and verify if everything is correct, actually already have all the correct sections. So we create a more consistent workflow, which has a lot of benefit from making it more searchable, more easily understandable by people it is shared with. So quite a bit of an interesting collaboration between the human and the AI on that front. So to recap, we saw 4 capabilities demonstrated by large model, which are quite useful for cybersecurity. The first one is having reasoning capability, and we discussed as through scaling content review, but those reasoning capability and ability to process data without being trained is actually probably quite useful for other areas. Second, large model have the ability to understand complex content, which contain images, text, video, code, and so forth, which is make it quite useful for analyzing malicious document, but probably also logs and other type of content, which so far have been only been understood by humans. So quite a bit of a jump of capability that I think we'll find good use of in the next few years. Code understanding is, of course, the biggest one. If we can hopefully harness that power to reduce Windows vulnerability or eliminate other class of bug, I think the world will be a safer place with that. So that's really, at least for me, is the most exciting one. And last but not least, it is clear that having AI-assisted incident response is the future, and it's going to really, really make incident response much faster, which is very, very important, of course, to increase the security and to react faster to attacks. So all those capabilities all taken together is why it is likely that AI this time is not going to be a fad. I don't think it's going to be as fast as people would imagine, which is in a matter of months, but it is going to be in the next few years going to trickle in all our workflow and really help us regain the upper hand. So a larger takeaway of the whole talk will be, yes, AI is eventually going to give us back the advantage because the upside of using it are really, really large. There is, of course, the risk that AI is also driving offensive capability and lowering the technical bar, because if it helps people to write more offensive code or eventually help with exploitation, then it is indeed a risk. The one big question mark is around disinformation and deepfake and phishing and scam, where I think there will be a onslaught of that, and that we need to work around. And last but not least, I think if today AI for security is quite promising and quite exciting, there is quite a bit of more research and more innovation to be done before it is as reliable and as powerful as we need it to be to really, really get its full potential. Hopefully, this will get you excited to get into that domain if you haven't just done yet, and start to think about how you're going to use it. If you would like to apply some of those ideas today, I think you can look at your workflow and ask yourself which of those capabilities might be the most useful to you and where you can apply it, whether it's content review, maybe it is about having a faster incident response. It's really, really depending on your own use cases. In the next 6 months, I think you could try to think about where to add AI as a new use case, as an additional layer in depth to improve your security, and also start to prepare your workforce against the next generation of phishing and scam attack by educating them around AI offensive capability, in particular faking video, audio, and phone. People should now expect that even if you hear a voice you think you know, it might not be the right person. So thank you so much. I hope that was informative. As I mentioned, you can get a slide if you are interested. And as always, if you have any question, want to talk about that, reach out to me on social network. Always happy to discuss more about how we can use AI to help increase the security of our user and increase the security of the world. And hopefully we'll find a lot of interesting things to collaborate on. Thank you so much. Have a wonderful week.